Data isn't smart, people are smart, and we have to have smart people to understand how to use data. In the past, we've had this sort of balancing act between computers getting more and more powerful, networks getting faster and faster, but we left out the data part. And so now I think we've come back to the data part as one of the key elements of what we're doing. So when you start talking about smart data, what I think we're saying is adding data into the mix of the computing and networking. Network bandwidth now has been put on steroids by the 100 gigabit per second networks that we've got. So now we can get to the data, and the computing and the data can be in separate places, which we haven't had before. One of the problems, though, is taking the data and understanding what to do with the data. So when we talk about a data tsunami or high-end data or smart data, it to me seems like what we're saying is understanding that we have things in the data that we don't know are there, and using things like data mining techniques, statistical techniques, algorithms that understand how to look through data, sift through lots of data, scads of data, that's a technical term, scads, and pull out the stuff that we want from the data to understand the smarts that are there. So as far as the networking, National Science Foundation, I think, like I said, includes networking and the computing along with the data. Networking is important for a specific reason. You have to get to the data in order to utilize it. So we have satellites in space that are sending down weather data all over the country, all over the world, in fact. Temperatures of the oceans, temperatures of the air, the salinity of the oceans, or the carbon dioxide content of the air, whatever, a lot of different things. And that data is going to ground all over the world, and it's not even getting picked up. So what if we had that data in India, somewhere in the middle of India, satellite sending it down, because that's where the satellite is over? Well, now we have to get to that data. So the high-end networks that we're talking about these days are able to take the data and put it where we want to in a matter of time that makes it easier for us to analyze. It's something we haven't had before. We have several different groups on the campus that are working in areas like data mining. Our industrial systems engineering group is specifically targeting data mining, data analytics. The management school, in fact, is doing business analytics that take business data and try to analyze it. A lot of our scientists, if you think about the genome, how much data is in a genome? There's something like 500 gigabytes of data in one genomic analysis. And to take that 500 gigabytes of data and do something with it, and that's just one genome from one specific animal or plant, and you think about all the rest of the genomes, the biologists may have to sift through more data than anyone. If you think about it, one of the most high-powered parts of our brain is the visualization part of our brains. We imagine, we visualize, we interpret data from our eyes, from our ears, from the surroundings of the world, and we make sense out of it with our brains through something like visualization. One of the only ways to deal with these huge, vast quantities of data is through visualization. Visualization, whether it's taking real-time data or simulated data, putting it through whatever process that you want to, so that you can see a form that our eyes can then process in ways that our computers can't. I think visualizations are probably one of the more powerful ways of dealing with this huge amount of data. I'm not saying that you have a direct correlation between the data and a visualization that normal people can make sense of, but if you can train yourself with visualization to see the changes in the data through the visualization, multidimensional, then all of a sudden things can become clear to you that you wouldn't see otherwise. There's sort of a ghost in the machine, if you will, in my mind. There's things that we don't know. There's some magic involved. I don't know how, by straight definition of data, which is just numbers, facts, data can talk to us, but building intermediaries, computers, algorithms, and so forth that could filter data, that could understand bits of the data to then feed us the distilled version, may be what they're talking about. And it makes sense. We can't consume, we can't comprehend data in these vast quantities that we've got. It's got to be filtered, and yet we don't know how to interpret it in the algorithms and the computers that we have. So intermediaries is probably the best that we could do. But I think in the future, the big decisions in our world, we're going to have to be smart with the data and watch the data, analyze the data, bring the data to the forefront, process the data, and let the data talk to us about what we need to do rather than using our emotional context in making the decisions that we follow going forward.